Hello, welcome to this video. My name is Tianchun Yang and my student number ID is MAT 2409025. This video is an assignment for MAT 202 Mathematical Analysis 2. And in this video, I'll prove that the convex sets are path connected. Firstly, if we want to prove them, we need to know the definitions. This is the definition of convex set. Basically, we took two arbitrary points inside the set S, and we let the points U and V, and we could always find a straight line segment to connect them. And most importantly, the straight line segment needs to totally inside the set S. So the set S is convex set. And for example, geometrically, a solid square is also a convex set and a solid circle as we draw before. But if a star shape, and we only focus on the outer line, if we took 2 points, for example here and here, we could easily to find a straight line segment to connect them, but it is also clearly that the straight line segment is not inside the set. So that's why the star-shaped set is not a convex set. And now this is the definition of path connected. Path connected, we just need to focus on 3 requirements. Firstly is a continuous function must be continuous, and second, the function image of function is inside set S, and the 2 points gamma 0 and gamma 1 are correspondingly U and V. And geometrically, we could also say, as we draw before, the star shape set, and if we connect them like this, this is a continuous function. Yeah, it's like continuous function, and also the whole function is inside the star shape set. And the 2 points gamma 0 and gamma 1 is clearly the 2 arbitrary points, which is U and V. So the star set is path connected, but it's not convex set. And what is not path connected? For example, we have a triangle here and a circle here, but the intersection point are empty set. Yeah, we just took out the intersection point. And if we took 2 arbitrary points, for example here and here, we cannot to connect them without through the intersection point, but we have already took out the intersection point. That means the line segment cannot inside the set. That means this whole shape is not path connected. So after the definition, let's to prove that the theorem, which is let C be a convex set, and then the C is path connected. So here is my proof strategy. First, let's take 2 arbitrary points, U and V, inside the set C, and then we use the definition of convex set. And then we need to check all the 3 requirements of path connected. And if we've done all the steps, then we could conclude that C is a convex set, then it is path connected. So the final step is conclusion. So firstly, we just to let U and V inside the set C, and set C is a convex set. So now we just use the definition of convex set. Basically, just we know that there is a straight line segment, gamma t, that 1 minus t multiply u plus t multiply v, and this function is also inside C. So this is the final result of using the definition of convex set. Now let's to check all the three requirements of path connected. Firstly is that we need to make sure that the function, which is also the segment, is continuous. So that means we need to prove that the gamma t is continuous. We just to prove that limit when t goes to t0, gamma t equal to gamma t0. And by the way, because this is a polynomial, so this is definitely continuous, but we need to prove here. So this is equal to when t goes to t0, 1 minus t, u, and plus limit when t goes to t0, tv. We just to plug t0 in the equation. So this is the exactly gamma t0. So firstly, we have proved that the gamma t is a continuous function. And secondly, we also need to prove that the gamma t is inside the set C. And when we're using the definition of convex set, we have already proved that the whole function is inside C. So the second requirement is also satisfied. So the third requirement is that gamma 0 equal to u and gamma 1 equal to v. So we just to plug in 0 and 1 inside the function. And it is exactly that gamma 0 is u and gamma 1 is v. So the third requirement is also satisfied. So we have proved that all the three requirements are correct. That means we could conclude that for points u and v inside C, and if the set C is path connected, is convex set, then the C is path connected. So this is our proof to prove the whole theorem. And what I want to say furthermore is the converse of my theorem or the statement is false. That means if we know that a set is path connected, it may not convex set. It is similar like continuous function and uniform function. For example, if we know 1 over x is continuous function, but it is not uniform continuous. It is similar here. As we see before, we have already to draw a picture that a star-shaped set is path connected, and we could also to draw a continuous function. But if we draw a line segment, straight line segment, and it is not convex. So that's what I want to show. The path connected are not necessarily convex set. And also, so that means the definition of path connected is a little bit lower or weaker than the definition of convex set. So that's all my proof and also other things for the theorem that the convex set are path connected. And this is my bibliology of all my proofs and of the slides. Thank you for watching this video.